I found this cool feature of Hasura.
Oh, yeah? What is it?
It's actually really cool. It's a dangerous feature. You know how when we have like our serverless functions, you can't use set timeout because as soon as you send the response, the entire JavaScript VM runtime just shuts down. So anything you had queued up on the run loop doesn't actually get to run, which has been annoying because there's been times where we get an API request and we want to do something in 30 seconds and we can't. We just can't. And Hasura has a feature where you can send it a post request and say, hit this URL with this data. Basically, like make this fetch request to this URL at this time. So you can use Hasura as your run loop. Yeah, exactly. So I think all those problems are about to go away.
Gosh,
and we're
please don't.
Just throwing data at Hasura to queue out. It's funny, man. It's just
how about instead of that, we just use a normal JavaScript environment?
Yeah, I think that's going to take a while.
Welcome to Front End First. Actually, today we are going to be talking about JavaScript environments, aren't we?
Yeah.
Today we wanted to talk. We didn't have any specific kind of topic queued up, but we have been doing work on our site, so we figured it'd be worth talking about. Specifically, kind of the static dynamic stuff that a lot of folks in our circles are talking about these days. So you've been doing this work mostly, but why don't we start off by talking about kind of how we build UI from the beginning, and like we might talk a little bit about EmberMap too.
Yeah. Actually, I think we should talk about EmberMap because EmberMap had a very big influence on this. Yep. Why don't I talk about EmberMap? You can talk about build UI, and then I can finish
talk about where we are.
What we've been doing.
Awesome.
So EmberMap was a Rails API Ember front end, and we wanted to add server rendering, but server rendering in Ember takes a while. You can't really do it at runtime because it can take like 3 or 4 seconds.
Why did we want to add server rendering?
Great question. OG tags. And there were some just like, if you click the link on Twitter, you end up on EmberMap, you get a white screen, and then the JavaScript app starts running and starts painting. And there's just enough of a delay where the browser says it's fully loaded, but there's still a white screen. It just felt a little uncanny. And we knew that just sending HTML from the server would fix us.
Yeah.
So those 2 reasons.
Yeah. And for folks who didn't go through the period of like single app bundle SPA development like we did, this was, didn't have any sort of server rendering. So today you send bundles. A lot of times they're split by route, but they are pre-rendered at build time. So at least you have some HTML you're sending up. So there's kind of a gradient here where you go from 0 server rendering at all. You literally just have like an empty div tag that is going to be the root of your SPA application. That's what we had. And then you get the bundle and it doesn't render anything. You don't see anything in the browser until the JavaScript is run and calls enter HTML or whatever. Yep. But it made for a nice experience once you were on the site because any link click could be just rendered client side. All the data in the code was there. And so you didn't have to wait on the network at all. In fact, you could like click a link on an airplane that had very low like latency, low bandwidth connection. And once you actually loaded the first page, clicking around the site could be really quick. So, it was kind of this trade-off between the upfront loading and subsequent page navigation, but that was the architecture there.
Yep. So we still had this kind of request response app, but it was slow because of the server rendering technology we were using. And so what we did is we looked at all the pages that we want to server render, and we noticed like for every page it could be in one of 3 states. It was like you're an anonymous user viewing the page, so you're just like a random user in incognito mode. The second was you're a user but you're not currently subscribed, so you're logged in but you don't have access to view the content. EmberMap was like Build UI, was a video site, made videos for Ember developers, so just a little context there.
Yep. And some videos were free, some videos were pro. So
exactly. And the third state was you are logged in, and you have you're logged in and subscribed, and you have access to everything. And we noticed that we only needed to generate those 3 different pages for every user, right? It wasn't like accounting software where you see like your P&L and that's different for every user. In the EmberMap case, every user fell into one of 3 buckets. So what we did is we basically like poor man's build. This is before like SSG or build time stuff really existed. We would basically generate the HTML, shove it into Redis, and then when a user visited the site, we would just do a quick auth check and then serve one of those 3 versions of the page they were requesting. And it was all from Redis, so we didn't have to wait on code to generate any of those pages. So no, it didn't matter if the runtime stuff to generate those pages took 4 or 5 seconds, 3 or 4 seconds. We could just serve it right from cache. And so that ended up working pretty well. And if we ever had any, let's say we ever had any like truly user content, things like your receipts and your invoices, we didn't want to put those in a cache. So what we would do is we would never initially render those. The client would make a fetch request to an API to download those, and then like it would basically be JavaScript rendering, CSR rendering. That kind of gets called that today. Mm-hmm. So yeah, that was the approach, and it worked out well. And you can talk about kind of how that influenced our future decision making.
Yeah, sure. So yeah, that was like you said, it's not accounting software. You know, what we recognize about the site, which probably also came from a lot of what we did when we worked at TED. We also worked on media sites, and you can kind of break down a site. If you look on like the pixels on a given screen, how many of these pixels are the same for every user and how many of them are different? And if it's like 95% of the pixels are actually the same, you know, you're signed in to watch a video on like TED.com, but you have a username that's different, but everything else is the same. The talk is the same. Then that tends to bend that curve more towards wanting to do the work up front and share the work across users. Whereas something like, you know, YNAB or Bank of America might not make sense to try to architect it in a way where you can pre-generate the page because 90% of the pixels are for the user. And so going from there to the Ember SPA to like the Redis cache made us realize that, right? And then, you know, basically that was in 2015, I think we launched EmberMap, or 2016? 2016.
Yeah, around that. 2016.
Yeah, 2016. And so about, you know, 5 years later, here we are. 6 years later, 5 or 6. And obviously like the SSG pre-generating public pages thing is a big part of the ecosystem. And it seemed like a great fit for Build UI because Build UI is in the same category where even though there might be like an overlay for people who aren't logged in or don't have access, the video thumbnail is the same for everybody, the title, the description, most of the page that you see is the same. Kind of, or so we thought, right? And that was enough to say, okay, this is going to benefit greatly from this architecture because you can't get much faster than a pre-built HTML page on a CDN somewhere. That's the idea, anyway. So when we built Build UI, we used Next.js. Next.js has runtime data fetching methods, but it also has a really nice setup for doing static generation, and that's kind of how we approached it. Now, in spite of like 90% of those pixels being in one of 2 buckets, either you're signed in as a subscriber or not, they're still the same for each user. So it's something, there's this kind of continuum from like static to dynamic, but dynamic, the word dynamic doesn't really capture everything, right? So we basically fetched the data we needed from our backend, pre-built all the pages for each video in the site, but we still needed to have some dynamism to show, hey, you know, you don't have access to this video. Also, we wanted to hide the pro URL that's coming from our backend so that people couldn't watch the video if they weren't signed in. Of course, you don't want that in the static page. And so we do that on the client as well. But you kind of have to have some logic there based on the user session. And there's a couple techniques you can do that while still leveraging the kind of SSG architecture, which we've learned from, some of the work we've done. Also, people in other communities like SvelteKit community, I know does this as well. You can kind of run some JavaScript right before you render this page and just basically toggle some sections or not. You could do it by adding a class to like the body tag and then like showing or hiding things with CSS. You don't want sensitive data coming through because people could just look at the source. But as far as the UI is concerned, that would achieve it. And it's nice because it lets you build this incredibly fast site and still give people the UI that is appropriate for them. But it's a little hacky.
Yeah, let's go into a little more detail there. So when we're statically generating the site, we're generating one HTML file, and we include everything that non-subscribers should see in it and everything that subscribers should see. So like if you were to look at our HTML, it'd look like almost like two sites kind of like rolled up into one. And then before our HTML, before you see the HTML, we have a blocking script tag that runs as like the first line of in the head tag. Right. And that figures out if you're logged in or not. And then it basically, or if you have a subscription or not.
Right.
And if you do have a subscription, it hides the quote unquote free version of the site that's in the HTML.
Right.
And then the opposite. If you don't have a subscription, the paid version of the site is still there. It's just hidden from you.
Right. Exactly. So again, people use this on as it's kind of like a little technique for just if you want to augment what is typically a static site with a little bit of dynamic behavior, you can do it. We first saw on a blog where the blog is the same, literally the same for everyone, except you have maybe a banner at the end that says, hey, check out our service if you're not signed in. So the actual blog page is the same. You can imagine being like Tailwind blog. Tailwind, CSS.com is like a docs site. It's the same docs for everybody. But what if they let you sign in? Maybe like they would say, oh, if you're signed in, we know you have Tailwind UI. Don't put an ad for Tailwind UI on the side of the docs. But if you're not, then you can show that. So you could build this whole thing and it would be a good candidate for like SSG because it does save you a lot of work. But then you have this little piece of content, like you said, that maybe you just check a cookie, and you toggle that. And you can do it in the blocking head section with some blocking JavaScript. We do this in like _document in our next app, which is where we've seen that done. Again, like I talked to Rich once and he said it's a really nice technique actually to use. Even in our SvelteKit project, we do that sometimes. For like seeing the user's preference on dark mode is another good use case for it. You don't know at the server time, so either at the request time from the server or at build time, whether the user is going to have a preference for dark mode or light mode. So you can run some blocking JavaScript, toggle that class, and that way the first paint they see of the site, even though it's a statically generated site, will have the correct styles. So this is like another example of that. So we kind of did that because in our minds, Build UI seemed like it was a mostly site that was mostly static. Even though it was like two buckets, it was mostly the same for them. And we like making these sites that are like really fast because it's just satisfying to have a site that's like that feeling where you just click on it, it's instant. But that's kind of where we started last fall. And, since then, as we've been building the site out, adding more features that we want, it's become apparent that it's more of a dynamic site, right? And if you look at those pixels, maybe they're not 95% the same. And in fact, the more features we want to add, we don't want to have to think about that. So, the thumbnail of the video is the same. It's true. But, for somebody who's not signed in, they have an overlay that tells them this is a pro video. You have to subscribe. Click here to learn more about it. And the way you do this is not the same as how you would conditionally render dynamic content normally in a React app. So you kind of you end up with these two paradigms. And it just puts more cognitive load on the developer to think about it. And really, it feels like a technique that would be good if performance was like this really critical thing or you were having performance issues at the beginning. But nobody would do this by choice to start out with if it wasn't a constraint that was forced on them. It's much easier to just fetch the data. Oh, I know I have a user who's signed in. They have access. Do this. Else do this in normal like ternary expressions in your React components, and having the data in JavaScript. No blocking JavaScript that runs ahead of time, no toggled CSS class. We just conditionally render content the way we always do in React. Mm-hmm. So that kind of sets the stage, I guess, for some of the work you've been doing.
Yeah. So just like to talk about some sort of potential solutions here. Like one is we talk about like, what is it? The lowest common denominator of the page that everyone should see. So it's like everyone's going to see a header. Everyone's going to see a title. Everyone's going to see maybe like the video play time.
The description, what's up next in the series. Yep.
Exactly. So maybe just server render that and then have the client basically fetch the other data at like browser runtime based off who the user is. So if you have a subscription, you start fetching the video file. If you don't have a subscription, you start fetching like the overlay for the sign up and all that stuff. But we didn't want to do that. That we kind of quickly, I know that's like a fine idea, but we quickly shut that down because we don't like how when you visit a website and then stuff starts flashing and you kind of have to wait a few paints before you're supposed to see what you're actually supposed to see.
Yeah.
There's versions of this I think we could make like tasteful, but
yes. Yeah. So you're talking,
I just want to acknowledge like why we're not going down that road.
Right. So you're kind of talking about kind of where we are in the current journey. So kind of everything we just talked about came us this decision point where we're trying to shoehorn more and more dynamic features into what's essentially a static site. We end up with multiple paradigms for conditionally rendering dynamic content. And the main pain point there is like, we just don't want to have to think about that. We want to be able to move faster on dynamic features on the site and not have to think about that. So then the question is, well, what do you do now? And that was kind of that is one option there, which is basically kind of what EmberMap is almost not quite, because EmberMap had the ability to give you two different versions of the site based on the user at runtime because the cache was used. And like you said at the beginning, we served up the correct page from cache after we do the user check. Whereas now we have effectively the site is cached because it's statically generated, but the static generation part is all done for us automatically by Next.js, and the hosting at the CDN layer is all done for us by Vercel automatically as well. So that's nice because there was a lot of code we had to write for EmberMap to get this Redis cache working, and it was just like something we did by ourselves and had to figure it all out. But it's not as flexible, so we couldn't do that, and that's kind of where we ran into this problem. So that was like the problem and the decision point. And like you just said, one node down the tree, the decision tree here is keep as much static as we can and do client-side stuff to add the truly dynamic stuff at the end. We didn't want to do that because we really just wanted to simplify the architecture, have one decision for how to fetch data, one way to fetch data, one way to conditionally render data. And if you want server-side rendering, which we do because we're a media site, people share our videos on Twitter, and we want there to be OG tags with images and all that good stuff, among other things. We want server rendering there. So doing dynamic data on the client at all is kind of like not really what we want to do because we want that one paradigm.
Yep. Another option, just to cover, it's more of a kind of like an advanced Next.js option, but what you can do is you can generate multiple versions of a page in Next.js. So you have the file on disk would be something like video /_ logged in.js. And that's like a page, a Next.js page. And then another one that's like video / logged out JS. And another one, for every version, you can create a new JS file. And you statically generate, let's say 3 or 4 pages. And then you use middleware at request time to check if the user has a subscription, if they're logged in or not. And you then basically you do a rewrite, which you can think of as almost like a redirect, but the user doesn't see the URL they're being served. So the user's browser, the URL stays the same, but they get a different piece of content, a different page you generated. And this can work nice, but there's kind of 2 reasons we didn't go down this road. The first being that it's a little confusing to us as developers. Like if we have one URL that maps to multiple pages, just a little hard to wrap your head around.
Yeah, it's not on the happy path of the framework. And part of the reasons we like using a framework is a next developer can come in, and if I'm looking at a URL in the browser, I can easily find the code that's generating that page, and now you kind of lose some of that.
Yeah. And then the second is because you're statically generating this page, you kind of get like this multiplication table, where if you have like 2 features that should be statically generated by 2 features that should be statically generated, you end up with like 4 pages. Every feature you add it grows like exponentially, right? So, yeah. So
Right.
I just want to acknowledge that because I know that's something we looked at, and it's a nice solution. It is a nice solution in the sense that you do get the bucket architecture.
Yeah,
that we talked
so
about earlier.
that's what I was going to say. It strikes me that it's almost equivalent to what we ended up with EmberMap, and EmberMap is not equivalent, but it's similar in that you have a proxy layer.
Approach.
You have a proxy layer that is sitting in between the stuff that is able to be pre-generated and the request, and the proxy layer can use some runtime information in order to route you to the right entry in the cache. That's effectively the idea there.
Yeah, exactly. One thing that's a little off about this is that in the EmberMap version, you don't have like multiple files. You have one page for a video. So, you don't have multiple versions of the page.
And
that's
part of the confusing thing about going off a happy path. And I actually think this could be a pretty interesting like feature that tools like Next or other sites that support other frameworks that support static generation could offer. And I actually think if they had it, that is what we would have used at least at the beginning.
Of course, yes. I just want to echo everything you said. So go ahead.
If you got a prop into your page that specified a bucket, a version of the page to return, and you could use that as a cache key effectively, and that's you would specify which props are the keys that key the page, that version of the page. And that's the same for everybody or different for everybody. Because caching, it's not just about static generation versus not. It is a continuum. And even though there are multiple versions of Build UI, because it changes whether you're logged in, logged out, and have a subscription or not, you can still break it down. If you were to look in a bucket, there's, a third of the page, a third of the users see one thing, a third of the users see another thing, a third of the users see another thing. Now, they all have their email in the header when they're signed in, so that part is different. But again, if you broke it down by pixels, once you're in one of those predefined buckets, you are looking at 99% of the pixels are the same for everybody. So that's where caching does kind of come in and it makes more sense. Whereas something like accounting software, there are no buckets that are shared across users that make sense. So it's not really worth it to cache in that sense. In that case. So that strikes me as a feature that would make sense in these sorts of frameworks because it's not a black and white decision. And one that we would have used. And EmberMap, again, basically does use at a high level the buckets architecture. And if you go click around EmberMap, it's very fast. Even though it was built 7 years ago before people were really talking about SSG as part of these dynamic frameworks, it's really fast. It works well because that work has just been done once for those different buckets. There's also some prefetching we're able to do on the client, but even still, Ember was not made to generate responses at runtime from a server process that's not like on a MacBook with nice GPUs and all this stuff, right? That came after the fact, and so the caching and the buckets thing it works really nicely even with years old architecture. So that's just interesting to me that I hadn't really thought that could 100% be a feature, but since it's not a feature, we just want to stay in the happy path with the tools we're using. So
yep, it's interesting that you brought up using like the props to control kind of your buckets or your caches. I really like that idea because if we want to put an email in a prop and we want to like blow away our cache hit ratio, like that's on us, but it gives us it gives us like, oh, we want this to be shared, so these are the props. I really like that. It's kind of like the entry point into this.
Absolutely.
We're creating multiple pages and then using the middleware to rewrite between them feels too it's like you said, not happy path, too low level.
Yeah, you could literally I think if I snap my fingers and this were a feature, you could even automatically cache the page by the page props because you're fetching the video, you're fetching so you have the video ID or whatever, and you're fetching the user's auth state. And so you return the video, and then whether you're subscribed, anonymous, or a guest, you're a subscriber, or you're logged in, authenticated, or whatever. And it would just automatically cache by those three things. And so if one of those change, you can break the cache or evict it or whatever, and otherwise you serve that page up. And then you would just, if you had user specific data that, like you said, if you fetched it in getServerSideProps or getStaticProps or whatever, that would become a cache key automatically. So that would defeat the purpose. But once you learn that, you would be able to fetch that on the client if you wanted to just get the user's information up there. So that would be a pretty awesome API. I'm sure that will eventually make it into at least some of these frameworks, because conceptually you're at the same URL, but you have multiple, just a few versions of the static content. So,
cool. And then I guess we'll talk about the third option and kind of where we ended up going, and that's just traditional server rendering. So you get a request, you look up the user, find out what they should or should not have access to, and then render on the server and send that down. Before we talk about that and like what sort of things we ran into there, there was something that I think it was like at this point in the journey where we realized what there's not just a continuum between static content and dynamic content. There's also a continuum between static content and user content. So, do you want to?
Yeah,
talk about
absolutely. So, going back to what you said and where we kind of ended up heading, it's basically like if you went back to Next when they introduced getServerSideProps, because that is a normal architecture of a PHP site, Rails site. GetServerSideProps is a hook that runs at request time and then responds. So the question is like, why did a lot of the community move towards the SSG stuff? Well, those hooks, that hook, getServerSideProps, are the equivalent in what like the JavaScript ecosystem was using. There is a lot to make sure like a runtime site like that stays fast as it scales a lot. A Rails site is very fast, especially for a company like ours, a website like ours that's starting and has, I don't know how many visits we get, but whatever the equivalent of like hundreds of users, in different buckets is. And that will last you for a long, long time. But, Rails sites do need to be tweaked as they get bigger. You have a single server, and so there's all sorts of techniques for doing that. The kind of the extreme end of that case is, again, like some of the sites we worked on at TED, which used Rails at the time we were there, and needed more than just one Rails server. And the kind of complexity, this jump in complexity from kind of what you would get in the guides in Rails to something that would work at a scale like that is big. There's a lot involved and there's a lot of decisions to make. So SSG and pre-generating just static files, it is in a lot of ways, it sidesteps a lot of those decisions and a lot of the complexity that you need to get a runtime site to be able to scale like that. And again, as long as it works with these constraints of being like mostly the same and not having different buckets and all this stuff, it is a very easy way that something like a tool, like a framework can do to take all of that work off of your plate. If you can get your site to be a static site and show the tool how to do it, boom, you're done. It's like you can have an article go crazy bananas on Hacker News and not worry about it. So that's kind of the mindset that a lot of these tool makers had, and the problems that they were solving because their biggest customers were running into those issues, right? And tools like e-commerce sites, which have lots and lots of pages, lots and lots of customers. And again, conceptually, it's like we are consistently running into resource issues and, servers dropping requests and all this stuff because they're generating all this stuff, and we're getting spikes of traffic at shopping times. And so look, what we can do is just pre-generate this stuff and then CDNify it, and we're good to go. And those shopping pages, like an Amazon page, look like mostly the same for most people. So that is a case where the problem is big enough that we have to address it with this technology. And it is amazing that all of the caching stuff that we saw, all the CDN, all the varnish code, all of the different options, the different ways you could go, you don't actually have to do that, and you can match. It's gone, and you can match the performance of those teams, those app systems with all those layers by just create next app, push to Vercel, and done. So that's amazing. But what we realize is that and then that's what also motivates the subsequent improvements to these systems, like Next.js has the incremental static regeneration. So now that you have that, and Gatsby was like kind of the first way we were introduced to this. Gatsby was the original one that said, okay, we are having a way to query your data with like the content mesh and GraphQL, but once we get it, we can just statically build it, distribute it, and you're not going to have scaling issues. But what you do have is that you have build time issues, right? And so now what we need to do is address that, because we're not running into the issues with serving your page, but your developers are complaining because you make a change to a blog in your CMS and now you have to rebuild the site and it takes a long time. So then you have things like incremental static regeneration, which came with Next, which is, okay, how do we just basically, again, it's an API for evicting a cache entry and regenerating it the same way EmberMap has it, the same way we had our systems at TED. Anybody who has wired it fastly themselves has ways to do this. It's just nicer APIs for doing that sort of thing. And that solves that problem very well too. So now you can have your CMS, your backend data source scale, in size and grow, but it doesn't have that commensurate effect on your build times. And so you have like a linear cost on the build time increase as you need to evict cache entries, right, with this approach.
And the interesting thing here is like all your static site in a way just became dynamic, because when someone updates the CMS, that's like changing data in a database, that's dynamic data.
Right.
But you have the ability to just evict, the 2 or 3 spots where that data is used. You don't have to rebuild. You're no longer in this frame set of, we're a static website, so we have to rebuild and reship to the CDN and blah, blah, blah. It's they give you the performance of static, but the tools that truly like dynamic sites, like an e-commerce site that has its data stored in a CMS or database would need.
Right, exactly. And so now you have this notion that's like, well, static is super fast, but we have a dynamic site. Well, you can have your cake and eat it too. And that's where this notion of like static performance, but dynamic data comes in. And so, all that kind of has happened, and we've been like living through that over the last like 5-6 years. And then we go through this journey that we just outlined with Build UI. And kind of one thing that we realized talking about this and some of the frustrations that we had with having 2 paradigms for, rendering dynamic data basically is kind of what, at the end of the day, what it is. There's other issues too. There's definitely other issues, but that's like a big one, is that not only do we have a dynamic site, we have... So there's different kinds of dynamic sites, right? And the Amazon page is dynamic in the sense that their catalog changes all the time. But if I send you that product link, it is the same for you and me, right? So it's dynamic because the data is changing often enough that it should live in a database, and that database changes regularly. But then you have the kind of sites we were talking about with accounting software. So you say, well, accounting software, QuickBooks, that's a dynamic site. Obviously, the data lives in a database. Why doesn't that fit the needs and the constraints of these kind of like static systems where these tools can automatically cache it for you? Like, that's dynamic, but we could just use these tools and make it static and solve any scaling issues that we have or performance issues. But what makes the accounting software different is that the dynamic data is user specific. So there are no buckets. There are no lines you can draw that would give you buckets that you could put in large groups of the users in for the dynamic pages on the site. And so that's an example where this architecture is actually not what you want, and it's not good. And what we realized is the more and more kinds of features we want to add to Build UI, fit more along the user dynamic data than just the general dynamic data. And so like in EmberMap, we had video views. If you've watched a video, we have a little check there. Or you have like a watch list, right? Or the settings pages that you were talking about and managing your team and all that sort of thing. You could imagine adding recommendations for that user, adding paths that they've been through, all of that sort of stuff. Actually, even though it's dynamic, it's not enough to just say, yeah, that's a dynamic feature, because it's a dynamic feature with the user in mind. It's user-specific dynamic data, and that falls outside the lines of kind of this architecture. And so that was kind of a realization we had, is that this kind of static-ish architecture is good for solving performance problems for non-user specific dynamic data. But if you don't have performance problems or you have user dynamic data, then this is not really, it's not worth adopting those constraints, taking on those constraints if you don't have those problems.
Well said. That was great.
Thank you.
So, okay. So, where we end up is, I think, we looked at like, there's a few things here. So where we end up, we want to do the server rendering. I think a big reason for that is we thought about the rendering in Rails and rendering in PHP. Request comes in. You can basically do a bunch of if statements based off the state of the user that's making the request and return different HTML. So we kind of end up at wanting to use server rendering to solve these problems. I think there was another layer too, is that, in the past few months, there's been a lot of talk of React Server components, doing more work on the server based off the request, and then also seeing our experience with Remix and basically having one place to load data and then feed that into to the React components. So I think a combination of like those three things really just said, well, we should just make a request response based website. Also, too, and just we know we don't have those scale issues. I would like to have those scale issues, but we don't. So.
Yeah, no, that's a great point, and I think it's worth, as a side note here, there's a reason people started doing more work on the client, because it lets you make more interactive, rich experiences. You can make sites a lot faster, not just faster, but you want to add more interactive, rich UI components to the front end. You're already writing in JavaScript, and as an aside, we considered going back to like client side rendering, because like the paradigm of Ember and Rails was awesome. It was even awesomer when we got to discover Asura, because now we didn't have like the 2-app problem. We didn't have to write a Rails app at all. We could just be in our JavaScript front end happy land. And also libraries like SWR made the whole data layer aspect even better than what we had with Ember. That we like it better. And so, to this day, that's still my favorite way to write apps, because you feel like there is never a point. Just like it sucks when you're running a static site, you hit a point where you want dynamic things and you're like, oh man, my hands are tied because I'm like I've like put these static constraints on myself. If you're doing request response and you don't have a paradigm for front end stuff, or you need the data to do an optimistic save, or you want to on hover load some data, you can't on hover load data from a server function because the user's hovering in the client. And so the client side architecture of doing the kind of API layer and going all to the front end, still my favorite way to write apps right now, because you never have those constraints. And we know we'd want to be able to add, a floating YouTube player, all these sort of things. And not video player, not YouTube player, but so we talked about doing that. But for exactly the reasons you said, we felt like it'd be going against the grain of the way that the major frameworks are moving and encouraging people to go. Now, a lot of the frameworks encourage people to go SSG, but it wasn't the right fit for us. This feels a little bit different also because React, the actual library, which is what we use, is going towards like server components and encouraging people to fetch data in the server. A lot of things fall out from that. You want the user session in the server. You want to be generating a lot of work from your page at server, on the server at request time. So those were the reasons, in spite of what's in my heart of hearts, that we didn't get to do our client-side rendered app.
I did say that after this whole experience, now is the time to convince me to do client-side rendering. I will say with both Remix and with React Server components, it does seem like they are both able to bend that trade-off curve in like use a server to load data and feed it into your components, but then use your components to build those rich experiences.
Right.
Just don't use the components to load data.
Right.
So it does. I do feel
it's a lot better than 5 years ago or whatever. Or whatever we used last time.
It's going to be super interesting though, for sure, in like 3 or 4 years to retro. Like basically, we should review this.
Yeah. Yep.
This podcast.
Yep.
And,
that's true.
And see where we end up.
That's true. All right. So, why don't you talk about some of the work you've been doing basically that involves kind of identifying the parts where those the SSG constraints force us to make different decisions. And, like we said, Next has getServerSideProps, which is designed for this to begin with. So it's not like this framework doesn't support what we want to do, making websites like a Rails app,
Yeah. Yeah. I think, like our original, just like, let's hack the website together in a weekend, first version had getServerSideProps. And one of the things we ran into there was cold starts because we were using serverless. And so that was one of the things that nudged us towards that down that SSG path. One interesting thing that kind of didn't really think about, but when you're doing a lot of work at build time, you don't really care about latency because it's at build time, right? Like the difference between a 60-second build and a 70-second build is that I'm going to just say that it just doesn't matter.
Right.
So we would it's very easy for us to say, okay, we're going to ping this service, we're going to ping this service, we're going to wire all this data together.
Optimizing for ease of use, less code written, not worrying about if you're adding a service to do auth or to serve up your content, is it ready for a runtime to handle a runtime request kind of thing?
Yeah. Even just like kind of like an example, like you can just have like you're looping over when you're statically generating a site, you're looping over all the pages and you're statically generating them. If all those pages end up like duplicating their data fetch, you really don't care. Like you don't worry about that until you're in like the over 10 minutes of build time.
Right.
So it's just one thing. You just don't care about latency. You don't think about latency. So moving towards the request response cycle, doing that, the latency is a lot more just something you need to keep an eye on. So like, okay, we're querying Firebase for our users. We're querying Hasura to find out if they have an active subscription. We're querying the CMS to pull all the content out. That's like 3 different services. Where's our server running? Like what's the location in the world that's like in the middle of all those services? There's just a lot of things that come up. So I think that's been like the most interesting thing. I don't really have a great answer for it. I guess the thing is most of these services they do a good job being like runtime dependent. So there's all the service, like Firebase doesn't say like don't block a request response based stuff us. Well, so I'm still like working through this, but like they are made to run on the client. So
some of them are, yeah.
No, Firebase is made to run on the
Firebase
client.
is right.
Yeah, so it's weird that like now we're like blocking a request response.
They do have a Node API, so it's not like they don't have Node. They have Ruby SDKs. They have Node SDKs.
I know.
So,
but they're made to run on the client.
They were designed originally to run on the client. Yeah.
Yeah. Yeah, so that sort of thing has been interesting. I've been doing a lot of instrumentation there. Like that's like the best advice I have. Like rather than like don't do this or do it this way. Basically using log drain with just console time. It's like console time and console time end in JavaScript. So you do like console time and you say like fetching user. You run some code and then you do console.time end fetching user. And you'll get back to JavaScript will spit out a log. Says like a log that says this took 46 milliseconds to run
to fetch the user, like fetching user,
whatever was in between those 2 console times.
Right.
So that's been really helpful, and then sending that off to a log service and aggregating those and looking at it.
Yeah.
Yeah,
but yeah, that's kind of like you're preempting the performance potential issue there. It's not like it might not actually be a problem in the sense. It's just feels very different to work to click around the site now that it's runtime generating based on these services than it is in production right now because it's static and the jury's out whether it's actually a problem. Like it might be fast enough even in spite of hitting slow.
It's fast enough from like my point of view,
right?
But I think it would affect our decision. There would be decision making around what services we use.
I see.
Yeah, for sure.
If you are starting a new project and this was the architecture you're saying.
Yes.
But in terms of this particular project and the particular services we're using, it's not actually clear whether it's an issue or not. It's a personal issue for you.
No, I'm okay saying that it's acceptable.
Yeah.
But part of me is like embarrassed it takes 500 milliseconds to render a page. Like I think that's like I would also push back and I would say like we're using Firebase because it's quote unquote easy, but it's actually not easy because now we have this.
Well, not if we have to add things that compensate for it not being able to do its thing at runtime or whatever.
Right. So right.
So yeah, that's kind of you're trading one set of problems for another, but it's such a simple site relatively, and it should be able to. There should not be any like large scale architectural tools that we need to add at this stage of the game, right? But you're kind of trading one set of problems for another. So this is one of the marketing terms you'll hear, phrases you'll hear when these frameworks talk about SSG and the benefits of static, jam, stack architecture, how it scales, all this stuff. They're like, you're working with a slow CMS. Don't worry anymore, right? Your people can use their CMS and you don't even care as an engineer how slow or fast it is because you're doing the work ahead of time. And that is true. But again, if you're trading one set of problems for another because now you don't have like a dynamic runtime site. And so if you get to choose a CMS or whatever, and you can choose them that are fast enough and work together and run close enough physically to where your app server is running, you don't have to worry about it. That's one part of that decision tree. The other is to unwind the services and just do things yourself the way you would if you were starting a new Rails app and using your own local database that's next to your app server and just writing that code yourself or using libraries that have that code yourself as well. But there's a lot of things we like about the services, a lot of the services we use. So those are kind of the two parts of that decision tree.
Yeah, yes. But I will say it's not either or. I think you can end up kind of in the middle. So you can still use a CMS, but you acknowledge that like the CMS is going to be for like the authoring experience. And then maybe you have a webhook that when someone authors something in the CMS, it pushes data in, or you have
a Redis cache.
Exactly. A Redis cache that you fetch from, and then you automatically evict like every. No, you just
evict when we change. Yeah, exactly. When the CMS changes. So that is a part of this that's nice. That's like we have an episode where we talked about the CMS. That is something that is kind of discouraged in a traditional web app architecture. You want your data there, but then we realize like you have environment independent. You have data that is independent of the environment. So it's actually been wonderful having a CMS and making a change, seeing it development, seeing it in production, not having multiple copies. It's been awesome to have that. So I wouldn't want to give that up. But like you said, you can layer in the caching or, moving the data around if you need it to be able to tolerate the request response constraints, So, most Rails apps end up with a Redis cache anyways, like a Redis, having Redis as part of their architecture anyways, because there's things that take too long. And so that's a very common solution to that problem. And it lets you stick with the root architecture and not jump to having to do work ahead of time and then having this kind of like half static, half dynamic cobbled together site, right? So feels like as we go down this road, Redis will be something that we take advantage of for sure.
Yeah. I think, and to what you said earlier, I think that's where we look at, what is specifically slow. And then how do we solve it?
Right. But wait for it to be a problem. There's this phrase that we really like when we're coding or mentoring people too, because, a lot of people, I get hung up on performance or they think about it, pre-optimization is something you hear about a lot. People on Twitter are talking about lighthouse scores and request times for big e-commerce pages. If you're starting out a new website or with a friend, you don't need to be worrying about any of that. It's like pre-optimization. It's not a problem we have. So you don't want to sacrifice other things that are more important, building the site and the features that your users care about for something that is not even a problem you're facing. And the phrase that we like is, you want to make it work first, you want to make it right second, and you want to make it fast third. So this is like something that I think should be in the back of everyone's mind when they're coding. You want to take the easiest path to making it work first. So if you're trying to experiment with a new ChatGPT API, building a page, or you're making a library and you're trying to do something you haven't done before, you're just trying to make something work first. And that's all you should focus on. It doesn't matter how clean your code is. It doesn't matter how inefficient the algorithms you're using are. If you are having like an n+1 issue with the loop that you wrote, or there's a more efficient way to clone an array, if that's not the problem you're solving, you just want to focus on making it work. And so you want the input, the output, and that is all you should be focused on. And like I've mentored tons of people and see them falling down this path where you lose sight of that very easily because someone told me not to use this. Someone told me I should do it this way. You shouldn't be thinking about that. And then once you make it work, then you want to make it right, which is the fact that, which is the idea that code is changed a lot and code is read way more than it's written. And so making it right really entails making it clear, making it correct, making it bug free, and writing tests for it. And you want to be happy with the code. You don't want there to be debt in the code base. It's fine if there's debt there while you're making it work. You use some really inefficient way to do it or really unclear way to do it, but you wouldn't want to like finish with that because you want to make it right. And that also involves like making sure the boundaries are good and the public interface is small so that people don't break your behavior later, or it makes your code easier to change later without breaking the consumers of your code. All that good stuff that goes into basically design, right? Following good design principles of code. Then the last part is making it fast. And that's really only if it needs to be fast, but it's a good thing to make code fast, obviously, especially we're talking about building UIs. And so the interesting thing about the whole SSG world and like the Jamstack idea and like sacrificing everything on the altar of SSG is that you're kind of flipping those priorities. And again, it's appropriate if you understand the development of this architecture, because there's people who have been pulling their hair out trying to make their site fast enough for some shopping spree, and could be an incredible solution, and we've seen lots of stories about that. But if you're just starting a new app, it's not your main focus, it's not your priority. And so starting with one hand tied behind your back, just because you want to end up with something that is fast because people are telling you how important it is to make a site fast and nothing can be faster than a static site is kind of flipping it upside down. And so, once we kind of have talked through this, and again, you can go to Build UI right now and see it. I mean, if you catch this before we make the switch, but it is fun having a site that's basically instantaneous. But at the end of the day, it's not the most important thing, and there's trade-offs and everything. There's no such thing as a free lunch, right? So, I think that's a really good thing to remember, both on the small. In the small when you're coding, but also in the large when you're making these decisions about how to lay out your tech stack, is to make it work, make it right, and then make it fast. So, yeah,
we can clip that.
Nice.
Throw it on Twitter.
There you go.
Yeah. I do think on the performance thing, I do think there's these like frameworks have to solve performance in like the general case, and they have to work with like websites from A to Z, every single type of website, or make like explicit trade-offs that focus on, like SSG, like the whole thing you just went through, where with like app developers, I think you can like get away with a lot of code where you never have to make it fast because you're not trying to solve like a general case.
Right.
And yeah, like I always think about like the big thing where this dawned on me is that Ted in the early days of EmberMap, we're shipping like 100 megabyte videos
right
to our users.
Right.
So like who cares about 10 KB of JavaScript?
Yeah.
Like no one, you know what I'm
Yes,
saying? Like,
it's right.
and that's something that made me think like, oh yeah, like the JavaScript bundle size doesn't matter for us because people are downloading massive videos. Now
they really want there to be more gigabytes of videos on the site. Like they are banging down our DMs asking for more series. Like no one has ever said, "Hey man, I love that, but like the last 10 KB of JavaScript is not for me."
I know, and that's like the joke we always make, but it seriously, it was like the thing that really just made it click for me.
Yes.
Is that if the size of your bundle doesn't matter if the person is downloading a 100 megabyte video.
Yeah.
The reason they're going to your website is to download a 100 megabyte video.
Yeah.
And I think this is like, it's really easy to twist this and say,
it is.
I know. But like,
at the end of the day, yeah, if you're the business owner, you have skin in the game, you will learn that and you will know that deep down. And,
that's true. Ask me when my views on this stuff changed.
Yeah, exactly.
The day I started a business.
Exactly. No, and that's where all this stuff comes from is like, we don't want to be constrained and frustrated when our users are asking for a way to track their video views. Like we want to be able to make that as easy as possible without thinking about this stuff. And again, so that's where all this, there's trade-offs everywhere. It's no black and white. There's no silver bullet, right? That's the essay and in software. And look, we consulted with folks at big Ember apps. And their homepage being slow because it depended on all this stuff to render just their marketing homepage was like a real problem for them. And the fact that, look, we're still using Next.js because it still has all the tools we need. But it is amazing, these features that have come to these frameworks. The automatic route splitting and the ability to automatically statically optimize pages on a per route basis means you can have a massive bundle needed to render your Figma, editor. But the homepage that is telling you the marketing information can be statically built and not depend on any of that stuff. And when we started this, we had to do that kind of thing ourselves. And our consulting clients were really stuck because they didn't know how to do that. And they were doing all sorts of hacks to make that happen. And, and then we had to make our own decisions with a Redis and cache and a node server. And like, it's hard to do that stuff well. The fact that these frameworks do that automatically is unbelievable. But doesn't mean it's the balance there is to make sure that you don't misidentify your problems and start going too deep into a direction that's not intended for you and doesn't balance the trade-offs for you and what you need, So I think the end state of all this is like, and which is what we're seeing, is that all these tools get these capabilities and you don't have to just go one way or the other. You get to do what's most appropriate. It's just not always the easiest to know what's most appropriate, especially because a lot of the stuff is changing so fast and we're still relatively early in kind of this era. So yeah, but look at that. We got a podcast out and we didn't know how long that was going to take, but it turns out we can talk about this stuff for a long time. So I'm excited to see where this work goes and then just getting rid of some of the abstractions, some of the things we had in there to try to make it easier to render that dynamic content for the quote unquote static pages and having just one paradigm for it. And also seeing how long it lasts until I get frustrated that I don't have data in like a cache on the client and want to do something. I think I'll be able to manage that. Hopefully, it'll be interesting too with the React server components as they kind of stabilize out. I'm really excited that we're using something that will lend itself to that paradigm, if and when it's right for us. So, yeah, I also too, just to wrap, like, we did want to add this so that we could do single topic purchases. Yes. So that was like the main motivator here, that you could land on the Framer Motion course. We could tell that you don't have an active subscription, but you've bought this course. So that's true. That's now we have another bucket, right? And the cache key is more complicated. And then you have a subscription. Yeah, exactly. So I just wanted to say that. So now that like we are done with this refactor, we're happy with the result. We can now start adding this feature. So that will be coming soon. Yeah, no, absolutely. For folks listening who are interested in the content that we make, that's if you like our work, you like the videos that we make on YouTube, that's a way to support everything we do. We have right now a subscription based offering on Build UI. That's $29 a month. But a lot of people, hey, I just want to watch the Framer Motion course. I just want to watch the Tailwind course. we're going to be offering that, and you can just buy it as a one-time purchase. So yes, that and many more things, all the kinds of reasons we wanted to go with this architecture, and I'm excited to get it out the door. So I think with that, we can wrap it up. But any last words? Is that it? Long live request response.
Yeah.
Cool, man. Sounds good. All right, everybody. Well, thank you for joining. And that's 3 weeks in a row for us. Last week, I thought it was 3 weeks in a row. It wasn't. It was 2, but this was 3. So I've been having fun keeping up with these. We're going to have to do it again next week.
Nice.
Awesome. All right. Thanks, everyone. And talk to you then. Bye-bye.
See ya.